Good day, I'm John Mark Dacumos, and I'm with my group mates, Harvey Alejo, Ruth Ballesteros, Ralph Cantonos, Julian Marcelino, and Roy Michael Joy Moreno, and we will discuss the topic about hydrogen power plant. And to start with description, a hydrogen power plant is a concept designed for a new widespread source of electricity. Essentially, it is facility which uses hydrogen to produce electricity or electrical energy. Ang word na hydrogen here means pure hydrogen. So, hindi siya nahaluan or compound elements, but it is formed through hydrogen itself. So, walang nahalo or nabuo siya gamit ang ibang element. And now, let's talk about the working principle of hydrogen power plant. Large tanks of liquid hydrogen will feed into thousands of hydrogen fuel cells. These fuel cells are solid structures containing an electrolyte, fluid, and two terminals, much like batteries. So as we can see, the main parts of the hydrogen power plant is the hydrogen fuel cells. And itong hydrogen fuel cells na ito works much like batteries. So therefore, kung gusto pa natin maintindihan ang working principle ng hydrogen power plant, first we need to understand every details of how battery works, leading to working principle of hydrogen fuel cells. So here now the vital parts and function of the battery, consisting of electrolyte, anode, and cathode. Electrolyte is a chemical compound that conducts electricity by changing into ions when melted or dissolved into a solution. It can be a liquid or paste-like substance, mainly made of ammonium chloride, zinc chloride, potassium hydroxide, etc. Anode is usually zinc or usually made of zinc, metallic lithium, and lead or lead. While cathode is usually made in manganese dioxide, carbon, lead dioxide, and copper. And take note that the anode is negative side or reducing electrode of the battery, while the cathode is the positive side or oxidizing electrode of the battery. And to further explain how these three interacts with one another, let's go now to the schematic diagram of the battery. So as we can see, the picture shows how this electrolyte, anode, and cathode interlinks one another. The anode and cathode are being submerged within the electrolyte solution, and at the middle of it is the semi-permeable barrier, and this simply prevents the excess of the electrons within the anode side to go directly to the cathode side. And here's how battery works. On the side of the anode, the electrolyte and the anode forms a chemical reaction in such a way that it produces the excess of the electrons, making this side negative. And as we all know, that if there are too many excess of electrons, it will keep on moving, transferring from one atom to another in random. At the same time, it will repel or maglalayo on one another. And now, the resulting scenario is that those excess of electrons will try to look for a place where are fewer electrons. And for the side of the cathode, the electrolyte and the cathode forms a chemical reaction in such a way that it produces a substance that readily accepts the electrons, making this side positive. And once again, on the side of the anode is being produced is the excess of electrons, while in the side of the cathode, what being produced is an electron acceptor. Therefore, if we're going to interconnect the two along with their respective loads, the excess electron on the side of the anode will travel towards the side of the cathode, and that particular cycle repeats on and on until the battery depletes, or meaning ng depletes ay mag-drain hanggang maubos ang karga.
If we see it here into the picture, the battery, the positive terminal of the battery is on the top of the battery, or into the outer top part of the battery, and inside the battery there are the electrode 1, electrolyte, and electrode 2. And from the outer part of the battery, we will see which is the cover that is called the insulated tube or the separator. And on the bottom part of the battery, there is what we call the negative terminal of the battery. Next slide. How it works. Within the battery, there are few chemical reactions. An excessive number of free electrons are produced at the anode during the interaction between the electrode and the electrolyte. These unbound electrons oppose one another as a result, and they attempt to move towards an area with less electrons. Simultaneously, a chemical reaction takes place at the cathode, allowing the electrodes to receive electrons. The cathode is the only area for gas to go in a battery. However, the separator prevents electrons in a battery from moving directly from the anode to the cathode. Electrons can reach the cathode when the circuit is closed, meaning wire joins the cathode and the anode. In short, batteries generate electrical energy through chemical reactions. In a typical alkaline battery, for example, zinc undergoes oxidation at the anode, releasing electrons. At the cathode, manganese dioxides accept these electrons, and the electrolyte allows ions to move, completing the circuit and producing electric currents.
So, this is the diagram of the working principle of hydrogen fuel cell. So, yung fuel cell is nag-work siya similar sa battery. So, yung hydrogen and oxygen is being supplied by the anode and cathode side respectively. Ganito yung nangyayari pag yung diatomic particle ng hydrogen is nag-react with the catalyst na gawa sa platinum, yung particles ng hydrogen is nag-i-split into two molecules, which is yung proton and electron. So, yung proton and electron, ito yung lumilipat sa cathode side. Pero may twist. Yung proton exchange membrane, ang inaalaw lang niyang dumaan is yung mga proton. So, yung electrons is obligadong dumaan sa may connecting wire, which is yung nagko-connect sa anode and cathode, na nagko-consist lang ng certain load. Ang nangyayari naman sa cathode side pagkatapos makadaan ng protons and electrons, yung mga protons and electrons na nakadaan is nag-unite, and sa tulong ng catalyst, nako-combine ang diatomic particles ng oxygen na nagpo-produce ng byproduct na water vapor. So, as you can see sa figure, yung fuel cell is nag-work like battery na nagpo-provide ng continuous flow of electron, which is nagsusupply naman sa direct flow of a certain load hanggat may full supply ng hydrogen and oxygen. So, this is the schematic diagram representing the working principle of hydrogen power plant. So, this figure is only a concept design. So, merong dalawang tank dito for hydrogen and oxygen. So, yung hydrogen yung nagsusupply sa anode side ng fuel cell, and yung oxygen naman sa cathode side. To achieve quality output, kailangan natin ng around 1,000 of hydrogen fuel cell within a typical hydrogen power plant. So, during operation, yung byproduct ng fuel cell is water, which is substance na hindi nagkukos ng any pollution. So, dahil nga yung fuel cell is nag-work like battery, yung output niya is direct current. So, kailangan ng inverter para ma-convert ang direct current into alternating current. To avoid further losses dahil sa mahabang transition line ng power grid, i-connect siya sa step-up transformer and then sa substation to be sent out papunta sa grid.
Why explore it? Bakit nga ba kailangan pang i-explore yung hydrogen power plant? Una is because hydrogen is a very efficient fuel source capable of producing more energy per pound of fuel than gasoline. Nowadays, we already have the hydrogen-powered car and have a lot of cars that are powered by gasoline. Kapag kinumpara yung same volume ng gasoline at same volume ng hydrogen, mas malayo yung mararating o matatakbo ng sasakyan na powered by hydrogen. Ayon to sa mga previous studies in terms of efficiency. Next is, fuel cells have much lower emissions than combustion engines. Hydrogen fuel cells emit only water, so there are no carbon dioxide emissions and no air pollutants that create smog and cause health problems at the point of operation. Na-discuss naman na kanina na ang byproduct ng hydrogen fuel cell is water, while yung combustion engines powered by gasoline or diesel is maraming pollutants na byproduct doon. And when it comes to emission, check ang hydrogen power plant. Also, fuel cells are quiet during operation as they have fewer moving parts. These are the main ingredients of ideal hydrogen power plant. First is efficiency, second is does not cause any pollution, and at the same time, quiet operation. Kahit na maraming nakatira sa tabi niya, is okay lang yung hydrogen power plant. Sa mga na-discuss nga kanina is masasabi na maganda ang hydrogen power plant. Why it hasn't gone mainstream? Bakit nga ba it has not gone mainstream kahit na sobrang ganda na ng hydrogen power plant? Sa ngayon, there are only few, actually very few, hydrogen power plant that is in operation. And those few is still in trial and observation stage. And at the same time, capacity-wise, they are only using a fraction of energy. The overall operation of hydrogen power plant is not perfected yet, and marami pa talagang parameters ang kailangan pang ma-plansya. And yung mga parameters na yon are, una is yung hydrogen production through methane. About 95% of the hydrogen we use today is produced by a process called steam reforming. Yung steam reforming is ito yung kapag yung hydrogen is being extracted out of methane. At kapag yung na-extract na yung hydrogen out of methane, it produces greenhouse gases, especially carbon dioxide. Which is, yun na nga yung iniiwasan natin dahil sa lumalaking issue ng global warming, and it doesn't contribute much on our environment. Next is hydrogen production through water. The other production method is electrolysis, which separates hydrogen from water. The downside is that it's expensive. For hydrogen to reach its full potential as an energy source, scientists need to figure out a way to produce it inexpensively from clean, renewable sources. Isa rin to sa paraan para ma-extract yung hydrogen besides sa steam reforming. The direct reason why hydrogen production through water is not being totally present nowadays is dahil nga mahal ang proseso na ginagawa dito. And may mga techniques na machines which are used for electrolysis na connected na sa other renewable energy sources. Pero, hindi pa rin nagiging lower yung cost nito. Kaya up until now, mahal pa rin yung proseso ng electrolysis of water.
Next is the cost. The cost of fuel cells can be high given the use of platinum as one of the largest component materials. However, there is work underway to find non-platinum catalyst approaches. Next, why it has not gone mainstream? It is because of hydrogen storage and hydrogen leak. So for the hydrogen storage, scientists are still struggling with the challenge of how to store hydrogen. Because it has such a low energy density, hydrogen needs to be kept under strong compression to be viable fuel source, necessitating strong tanks and heavy-duty fuel lines, as there is currently no mainstream system of storage and distribution for hydrogen fuel. This is a major practical disadvantage. And for hydrogen leakage can occur during many steps of its production and use. Science magazine reported in June 2003 that hydrogen leakage from widespread use of hydrogen fuel would gobble up ozone faster than CFCs do.
Latest development in hydrogen power plant. We have here a project which is near completion, the Long Range Energy Generation Project. This is actually a 485 megawatts facility in Ohio, but we can see only 5% of hydrogen is the contributory factor in the 485 megawatts. And from that standpoint, we can still say that this project, when it comes to using green hydrogen, is still at its prototyping or trial stage. Although it says here that the company is planning to have a transition which will use 100% green hydrogen over the next decade. But scientists and engineers are still skeptic whether this project will materialize, and for that we can say that hydrogen power plant is still at its exploration stage. Another latest development. Here's a project being catered by Siemens Energy, which have just recently started. This one costs around 170 million euro and situated in the remote part of French Guiana. And to cut it short, this power plant actually offers a very little capacity when it comes to fuel cell. The hydrogen fuel cell here is rated at 3 megawatts only. Majority of this power plant output comes from the solar panel, which is 55 megawatts, and 20 megawatts from its reserve capacity, which is the sets of batteries. And once again, from this standpoint, we can say that this project is still at its trial stage when it comes to using hydrogen energy. With that being said, it is fair to conclude that developers and researchers of hydrogen power plant still have a lot of works to be done in order to propel this type of power plants to its peak performance.